So yeah, thanks guys so much for inviting me. I feel like I should be here with the rest of the team presenting this, but I seemed like one of the only, like older members that was interested in this, and I was like, why not? Might as well give my keynote speech practice a try. So this is talk's going to be a little bit less about the technology, and a little bit more about like my sort of experience with the club. I definitely at the end can do what I can to answer any questions on like the actual technical side. But I figured it would be a little bit more interesting going through my experience rather than just like recounting our design process. So yeah. Just wanted to make another huge thanks to the rest of the team here, all the other team leads in the past, some new and some old, some that have moved on and graduated, including myself. A few other members here. So yeah, a little bit about myself. I started out in physics and astronomy at UVEEC, and then I quickly realized that I wanted to build stuff and I wanted to be more on the like practical side, not the research side. So I ended up switching into mechanical engineering in second year. And then that was when I got to a point where I saw the UVEEC schedule, and they want you to take 6 courses a semester. And after third year, struggling through 5, I was like, I really want to commit time to a club, but it's really difficult. So I decided to split my my last year of school up into 3 different semesters rather than 2. So I did 3 of 4 rather than 2 of 6. And so I could dedicate myself to a club. I was working with a friend of mine, Eric. We ended up joining the UVEEC Robotics Club for a while, doing some software stuff, but didn't really work out. It was in the middle of COVID, and we were just not really super into it. We worked with a little bit of computer vision stuff like barcode scanning, but we kind of did our piece and left and moved on, looked for something new. That was in the fall of 2021 where we discovered UVEEC. They were like a brand new club, this brand new idea that everyone was like getting really excited about, and we could see the potential. We were like, this is something really, really cool. And we get to get in from the very beginning. So that's what was most exciting for us. For that part. So we definitely let's see, we met with the leads. They had a meeting and we got to talk with them one-on-one and really see what their plan was and why they were passionate about this specific topic. And my friend Eric and I knew, we were like, this is a new team with all these experienced people who are leads in the past. We know this might cause some issues, but like, is it worth the potential? Is it worth jumping into something brand new, even though we know there's going to be dealing with growing pains and stuff? So that's what we decided to do at the end of the day. And honestly, I've been just like blown away by June here. He's wearing the UVEEC mask all the way to the right there, and yeah, he's like the mastermind behind this whole thing. He pretty much just had the energy and the idea and like the dream to make this club happen, and that's exactly what he did. So yeah, I just wanted to give a huge shout out to June. Thanks to him again as well. So what was the actual project, I guess, is probably what you're wondering. What are microplastics? You guys don't need me to tell you that, but let's just do a little refresher on why we decided to tackle this topic. It's becoming more and more of an issue, especially in the ocean, with all of our waste, like over the years, continuously breaking down and leaching into the water. You guys know most of the sources of microplastics. They all come from us, whether, you know, they start out really small, such as like anything that's polyester, any poly, that's plastic, right? Anything like that, or any big plastics that have been sitting in the ocean and just like run over. Sweet. Okay. So after I met with June and the leads, I decided to join the filtration team. And this was kind of like the whole core of the project, it felt like, which was like, we're going to take this idea that bubbles stick to plastic because it's hydrophobic, and we're going to float it to the surface. Now, that is like a really cool idea. And this was kind of the thing that got everyone excited, was like, okay, like this technology has the potential to do something interesting. What can we do with it? And how do we actually, you know, how do we do this? How do we make it work? So we had a few different ideas. Initially in the filtration team, we had like quite a few members, all sort of working on different stuff, and mainly for like making bubbles. And then once the bubbles stick to the plastic, how do we actually collect the plastic? Those were our real main focuses. So we looked at, you know, some simple options like blowing air through tiny holes to make tiny bubbles, or using venturis as well, like a water pump with an air inlet that would create bubbles. So we ended up doing some calculations and deciding that we were going to go with an air pump, and connect to the battery. Checked it all out with the electrical team, making sure everything was good. This here's a photo of one of our venturis. Lots of initial testing. Like, it was really difficult for us to design or sort of like simulate this, at least like at our level. You know, we found it really best to just like get in there and get our hands dirty and realize, okay, this doesn't make tiny bubbles, this does. What can we do? So what we ended up settling on, you'll see here in this GIF, was a ceramic water filter that we pushed the air through, and that created those nice fine like mist of bubbles almost that we wanted. And then this here is just a cutout of our filtration module that's trying to show, you know, how the plastic is going to travel, how the plastic is going to stick to the bubbles and float to the surface. So yeah, we had the idea for the ceramic filter, and then this guy here actually on the left, this is my friend Eric, who I joined the club with. And then he was the one who had a final kind of design for putting the ceramic in, like, you know, in a little enclosure. Ilya was the team lead. He was the one that had the idea for the ceramic filter. Yeah, so let's see. Yeah, so this here is the MBGs, which we called MBFs, which we later called MBGs. Yeah, we ended up getting the fine bubbles we wanted. We just had to tweak, you know, tweak a few things, adjust a few things, reseal the fiberglass, just kind of all that sort of stuff.
Oh, so Nathan, you don't mind a question? It's the idea is the bubble generator just ends up putting a lot more plastic into the device. It's, you know, it's so you collect more plastic as a result. Okay.
Yeah.
And it kind of, I guess we're going to get to some interesting stuff. It'll like sit kind of in front of the machine and gather. Okay, cool.
Yeah. Sorry, I'm not specifically sure what you're asking. I'm just wondering.
Well, I guess I'm kind of wondering, where the microplastics are, and I'm just imagining they're and how they're kind of stratified in the water column. And
For sure, yeah. So that was definitely something that we considered, and like made sure of. The first thing, which sorry, I don't have a photo of, that June did even before the project started, is he went out with a team and they built a very basic filter just with like meshes, and they kind of went in the sand and shook it around. Unfortunately, we couldn't verify like, okay, at this depth, there's going to be this much microplastics, and this depth, there's going to be this much microplastics. And unfortunately, we couldn't really find any research that was like backing this specifically. So we kind of went into this entire project with the idea of like, okay, we're not really sure where the microplastics are. They're kind of evenly distributed. Maybe, I don't know, we're going to find out. I think that was sort of the attitude of just sort of like, let's make this concept work. Let's prove that, yes, bubbles do stick to plastic and they do float it to the surface. Yeah. Okay.
Thanks.
Yeah, no problem. Any more of those kind of like technical questions? I feel like I can definitely like go into the details at the end. Sure. Or you guys can stop me and ask me questions. Okay, so then let's say that this was through the fall semester and into the spring of 2022, we started to like move away from the club a little bit. My friend Eric and I found that there was like some organizational stuff that we knew we were going to deal with from like a brand new club, brand new leads, and a kind of like a large skill gap in the club of like a bunch of really experienced fourth year leads and then like less experienced new people coming in who are like really keen and excited, but don't really know what they're doing yet. So we were like involved in a lot of projects initially, and then because of like team members leaving or reorganizing, like what are we really doing? Should we design that? Is this worth this? Eric and I were feeling a little bit lost. So he finished off his prototype for that final MBF, creating those bubbles. And then we decided to move on, he decided to move on from the club. And this is when I was working a little bit in the summer. It's hard sometimes if you got like a co-op or other projects or all these things coming all at once, to keep, interested in a project that like you don't have a specific kind of role, it feels like. So during the summer, we had new elections for new leads because a ton of the old leads were graduating and moving on. And the project was supposed to be 1 year. It was supposed to be like fall 2021 to fall 2022. And unfortunately, the project ended up taking 2 years. And, like when you look at a year, you're like, man, that's so much time. But 3 semesters goes by really quick in school. So anyways, in this transition process, we're trying to figure out who's going to run the club now. And I was trying to decide if I wanted to be involved anymore. I kind of had the attitude of like, I really, I feel like there are a few things I want to do. I want to try to push this project to the next level. Like I want to be involved. But it's really hard, and it's easy to just like step away and be like, I don't really know. But luckily June came. He convinced me. He had that classic energy of like, yo, come on, man, like this is your chance to make a difference. You can do it. And I signed up, and I was like, okay, you know what? I decided to run as the team captain / team lead project manager. I ended up working with co-lead Julia. So we kind of split our responsibilities, sort of like 70-30, like project management, admin stuff. So we would work together on funding proposals, as well as like, the general meeting planning, all that kind of stuff. I don't know. Julia and I met like almost every day. Yeah, like at least 3 times a week, which was really good. Okay. So let's talk about fall 2022. So we've got a bunch of new leads. We got a bunch of new members. We've got a new school semester starting. And the biggest thing we're trying to do is get everyone up to speed of where the previous leads were. Again, just our new leads, as you can see, maybe you can't tell, but they were all pretty much new. So they were like first or second years when they became leads. And unfortunately, all the knowledge that like previous leads had, that a lot of it went with them. And then there was a little bit of like reaching out to them, trying to get stuff, figuring it out. So the first fall semester was a lot of like, figuring out what we're doing, reorganizing the stuff, getting the team leads to focus more on like working with the less experienced engineers. I know it's tough when you're like, oh man, I can do that so quick. And usually you can, but I realize that it takes, like it's more worthwhile. It's more of an investment to go with someone else and be like, here, let me teach you this. Let me walk you through this process here. So that next time when I leave, I'm not part of the club anymore, you know what you're doing. So yeah, that was something that we really focused on. Yeah, just some of like the photos of the club room of us, stuff we were going to organize, meetings, discussions, planning. Okay, so another thing that we dealt with, which was mostly my fault, was scope creep. And that was kind of like the mechanical team didn't have anything to do other than manufacturing because they had gotten so far ahead of everyone else. And what we wanted to do was give them some design work to work on, because that's what the members were requesting. And it makes sense. They want it for co-op applications. They want to have that design experience. So we started working on this like filtration module testing ring sort of thing for maybe like a month or two, and we never really got anywhere with it. Luckily, June came in and gave us some advice and was like, hey, like what you guys are dealing with right now is scope creep. You need to focus on like what's really important. That's getting the boat done and getting it in the water and testing it. And I was like, okay, yeah, like I think you're right. And we definitely moved past that. Manufacturing team. In the fall, we did get some new storage space, though. That was really the theme of the fall, was just kind of like reorganization, planning, like, getting all the basics in order. Another really, really important lesson that I took from working with the club was pretty much done's, and also like being proactive to see how projects are doing. So when the boat was meant to be done in fall of 2022, it was pretty much done. The mechanical stuff was pretty much done. The PCBs were pretty much done. Unfortunately, pretty much done, I've learned, is not the same as completed. And like pretty much done projects require special attention, because otherwise they'll sit at pretty much done for months. yeah, so that, and also like learning not to wait, or like how to wait for suppliers. This is like a question I'd love some feedback on later on maybe. But like, when is the right time to be like, you know, we just can't wait for this part to arrive, or like we can't wait for this part of the project? Because that was a common problem of like, oh, we need to do this. Oh, never mind, this is done now. Let's do this. So trying to just kind of like, no, stay focused. I just wanted to give a special shout out to Taz. He was one member of the mechanical team that I found really stepped up. Like when the mechanical leads were both on co-op, he ended up stepping up and becoming like interim lead, and he was already doing all the manufacturing. He was already doing a ton of the design. He's been at all the showcases. Like, yeah, I just can't say anything. So I just wanted to say a huge personal shout out to Taz again. Thanks for everything that you've done with the club. I'm not sure if you're still involved in the club or not, but you know, the time that you did put in, it was really, really amazing. So thank you. So we're back to spring 2022. We've reorganized. We've brought our new team leads up to standard, up to the knowledge level. We've got things going. We've got orders coming in. We're trying to get the boat in the water by the end of January. We got a website going. We got our UVEEC.ca going. We've got some different pages on there, some sponsors, some photos. That was one of our big goals for our software team, because they were sort of waiting until the boat was done, until they could develop the like autonomous navigation system. We did end up doing some water testing. The thing is the electrical team had some issues with their PCB orders and stuff. So, you know, like what I was mentioning about waiting, things are pretty much done. We ended up just like pushing forward. It's like, you know what, we got to see how it floats. We got to see the weight distribution. We got to see how it moves in the water. So we decided to go forward with testing there. Eventually, we did get all the electronics installed. We got the battery manufactured. We got everything put together and the hull sealed up. Unfortunately, on this day, there was just a stack this high of, you know, almost dones, just about dones that the electrical team worked. They worked into the night before, and like the whole day of the testing, but unfortunately just like couldn't get it running yet. So we ended up pushing back our powered test with the motor and stuff. We ended up getting it running, you know, not in the water, but the propellers were spinning, everything was turning the way we wanted it to, so we were looking good to go. Okay, one thing that we didn't want to happen was a little, you know, a sloppy transition period this time. So we knew we'd be having new leads and a new project, even though this one wasn't completed. So that was really difficult, was trying to like focus on the current project and keep everybody focused on it. But like as the leads do the planning for the next one, so that as soon as the semester is over, the new leads can sort of take over and start the transition process over the summer rather than kind of like all at once. Yeah, so just so you know, our new project is a sea glider. I don't know. I guess if you have any questions about that, you can ask me and I can do my best to answer them. But yeah, the election process was pretty standard. Get some new members in there, get some new leads. So yeah, the reason that we kind of, I don't want to say cut the project short, but didn't like expand on it, and why we're not still working on the microplastic USV right now is because of the team burnout and the project burnout. So unfortunately, like because the project was meant to take a year, and it ended up taking 2, people were always in the state of like, it's almost done. Ah, man, I feel like it should be done. And instead of being kind of realistic about how much work there really was left. So that made it really difficult. And Julia and I, as the leads, ended up meeting with our faculty supervisor, Dr. Vallejo, and she suggested that like all the work that we had put in was great. And like the point of a club was kind of to go through this process and make mistakes and learn. And like, that was the point of the club. Building a cool technology and developing like something state of the art was very like, that was kind of the goal. But really what we ended up getting out of it was like design experience, manufacturing experience, like learning from our mistakes, all that sort of stuff. So that was why we decided to have a showcase for the microplastic USV. We put one on in September for our sponsors, and we decided to focus the club's focus on the new Sea Glider project. The boat did end up going in the water, and we did end up attempting an ocean test. Right on the day that we had an ocean test, we had like they were using the, I'm not sure what you call them, the diagnostic probes on the electronics, and something shorted, unfortunately. So we were really close, so close on the boat ramp. And this was like the day before our engineering showcase at UVEEC. So we consider that a success, having kind of like a final conclusion for the project, a conclusion for all the members that were here, and some sort of solution, I guess, to handle the team burnout. Because the main thing that we wanted was like, we want to keep the club running. Like this project is cool, but I think the vision of the club is the most important thing, of just kind of like having that, tackling those local issues, tackling those smaller environmental issues, and just like working and gaining that experience with the club. I think that's really the main thing. So yeah, at the end of the day, what did I get out of this whole experience? What did I learn? What did I gain? I mean, one of the biggest things that brought me into becoming the team lead was, the idea that maybe I can do good at project management. Like maybe that's something that I'll do well in this area. And I realized that it was an area that I strived in, and was something that came kind of naturally. Sometimes I'm not the most organized, but almost the organized chaos of the club, and being able to keep track of all these different little sub projects with everybody, and just kind of like, nurturing the younger engineers, working to develop their skills, was a lot more satisfying than I ever thought it would be. So yeah, I'm really glad for my time with the club, and I'm like glad I decided to stay with it, and that we did. We completed that project. We got that microplastic USV there, and did that showcase. Yeah, so I guess I just wanted to say thanks again for having me here, guys. I hope that was informative. Maybe not the technical explanation that you guys were expecting, but if you're looking for any questions on the microplastic technology, I can do my best to answer it. Thanks, guys.
Yeah, thanks a lot, Nathan. It was a personal story and kind of a fun trip through your adventure. I will open up the floor. We've got Ethan.
Yeah, thanks so much. This was a great talk, hearing about your experience in the club. Yeah, I guess my questions were maybe related to going back to like the value proposition of why you wanted to build this in the first place. Like, was there a specific industry problem or an academic researcher that was kind of calling for this technology? Or maybe you can just provide a little bit more context on what was like, the motivation behind the bubble curtain kind of project and how that was solving the problem that existed before you guys started the project.
For sure, yeah. So like I said, June managed to just kind of pull the project out of the depths, like just kind of this idea of this technology. And I guess the goal was to solve microplastics, or maybe come up with a new way of collecting microplastics that was non-intrusive to wildlife. And like you could drag a big mesh through the ocean, but unfortunately for microplastics, this just isn't practical, isn't really possible. And to do that without damaging your boat or damaging wildlife is difficult. So that was one of the main kind of attractors, I guess. Yeah. So I guess that when he brought that to Dr. Vallejo, who does research on water filtration systems, she saw the potential there.
Cool. Thanks, Nathan. We
Yeah,
got
did that answer your question, Ethan?
Yeah. So it was an alternative to a traditional Mantitrol or Newston net, a more non-invasive approach for collection of microplastics.
Exactly. Yeah. And I think the other thing was it was just like the application of this technology, like froth filtration, which already existed for like mining and stuff, and using it for this specific application. And I think there was one example of it before, which was like part of the inspiration to June. I think it was more so just like the idea that bubbles stick to plastic. But yeah, sorry, I wish I had him here to answer that detailed question. Sorry.
Great, thanks.
We'll move on to Fabian.
Yeah, thanks. I had a very similar question to Ethan, so now I'm going to ask something else. I was interested in that possibility of that glider application, where you want to deploy your technology on those ocean robots. What are the sort of like challenges that you see with that technologically and operationally?
So their idea with that was to build sort of a platform that would work with the kind of marine bio department at UVEEC. So they could build a platform, and then the specific professor or research or whatever it is, they would build a specific module. So the biggest issue I see with this project, I guess, is like actually getting something going. Because talking about, I know this professor, they're working on this, like actually it's like coordinating with them and getting the research going. And it's like, okay, these are your requirements, this is the budget, here's the timeline. I think those kind of things are going to be difficult, because I don't know if you guys can relate, but in the academic world, I find that things take a lot longer than you think they will. So yeah, I think that might be their biggest issue, in like having something to do it for, like specifically. But it sounds like they're already onto something, as far as I can tell. I've been a little bit disconnected from the club, but it sounds like they already have a certain project. CTD or something? Do you guys know what CTD is?
Conductivity temperature depth.
Okay.
It's
Yeah,
the
that must.
three main parameters that get measured in the ocean all the time.
Okay.
Yeah.
All right, that's a good one. I'll write that one down.
Yeah.
Yeah, so it sounds like just having a quick look, I don't know, today and like the last few days when I was, reading through, getting photos and stuff, I was looking through their stuff and I was like, man, I don't know what's going on, but good job, guys. I don't know. As far as I can tell, it looks like they're on the right track. And one of the leads, Johanna, she's very, very proactive. So I think that they're gonna like continue doing fine. I think they're just gonna keep ripping.
Okay, cool.
We'll go to Chris Carpenter.
All right. I just wanted to kind of expand on Ethan's question or clarify some things. I think you did a pretty good job of answering it. If I understand correctly, you're attaching air to the plastics, getting them to float, and that is a different kind of filtration system, right? Like, do you have any sort of a mesh in your system?
No. No, there's like a front grill, which is meant to protect from large debris. But no, other than that, it's just kind of the plastic and the water and the fish and whatever else floats through the sea of bubbles, is wall bubbles, and the plastics selectively float up and everything else just kind of floats forward. And here, wait, do you want me to show you? I guess I can go back to that GIF.
Yeah, it looked like it was there's a channel in the top of your channel.
Give me 1 second here. I'll just bring this up. All right. Can you guys see that? So here on the left is the filtration module. So the thing on top is the little T that attaches it to the rest of the boat. And the whole filtration module is made out of fiberglass. And then you'll see here on the top, there's like the little protruding area. That's where the collection module slides in. And that's where the plastic is meant to float up. Oh, okay. So now that I say that, I have to make a correction. In the collection module, there is a small amount of mesh. That is true. But the idea of putting it up in that kind of, water dynamic, like, more like out of the way, sort of. I don't know what I'm trying to say. I'm trying to say water, like more water dynamic. So that instead of having a mesh dragging through the water, it's kind of like protected, and then the plastic floats up and sits in the mesh.
Right. So you could have a finer mesh because less water is passing through it.
That's correct. Yeah, that's the idea. As well as, like there isn't as much surface area of mesh dragging along the water. So not as much drag. That was a big concern initially, was that the drag from the filtration module was going to snap the T right off. That was something I was really concerned about, but it ended up being not a big deal at all. So, yeah.
Great, thank you.
And Daniel.
Yeah, hi Nathan, thanks for the presentation. I know we're at marine beers, but I think it would be nice if we prevented the plastic from getting in the ocean in the first place. So I was wondering if you looked into applying your technology in something like a sewage treatment plant, or do they have better ways of doing it there?
Yeah, we've had inquiries from a few different companies, including some of the people here, reach out to us and talk about like applications of our technology. So I agree with you. I think that's a great idea. Unfortunately, with the club at school, with everyone being volunteer, it was difficult to be like, okay, this is our thing. We're going to keep working on microplastics. That's the only thing. Even as it was, there were a lot of people getting really burnt out. So I guess short answer is like, yes, I think that's a really cool idea, as well as for drinking water, because I have heard of microplastics being found in drinking water.
Good point. Did you the tests you ran? Did you do both salt water and fresh water?
So every time, even though we tested in that tank, you'll see all those photos. There's yellow buckets or those orange buckets. We went down to the ocean. Yeah, we got like, 2 Home Depot buckets of salt water. So yeah, we found something interesting. In salt water, the bubbles are finer, which helps a lot. But
Okay. So it may not work as good in a sewage treatment plant, which has fresh water. Well, I wouldn't call it fresh, but which has non-salted water because the bubbles would be bigger. Okay, interesting. Thank you.
Yeah, I guess it sort of depends. Our like theory and relative findings, but we couldn't put like scientific backing on it, was that like the smaller the bubbles, the smaller the plastic, and like the better it collected the plastic. So maybe in that case, you would just need to find a way to produce finer bubbles, like a finer mesh. Yeah.
Okay, thank you.
Thanks, Nathan. I guess there don't seem to be any other questions here in the queue. Maybe had one final one. Did you guys, or do you plan to write a journal article on the MBG or any of the work related to the USV?
That is a good question. That's something that I suggested. That's what we were working towards, with kind of like having the showcase, and then maybe putting out like a journal article, or like getting in the newspaper, something like that. Honestly, it's an idea that I think I'm going to bring up with the team again. But I think the simple answer is just kind of like everyone's graduated and gone off and started to do their own thing now. Yeah.
Yeah, that makes total sense.
But I think there's definitely some warrant to that. I think it would be more exciting if it was like part of the next step, like if it's like, okay, now we're going to hand off this technology to, right, and they're going to work on this as their grad project or something, like something along the lines of that.
Yeah, no, that makes sense.
If any of the other members are watching, hit me up. I'm down to write something one day, or make a video, or I don't know, put something together. This was my sort of culmination of the club, but I think a journal article would definitely hold some weight.
Yeah, I think it would be really neat. It's obviously a big problem, and your MBG looks like it's got some potential. So, but yeah, it looks like we'll leave it there, and we'll just give you another big Marine Beers thanks for presenting. Really, really cool. And yeah,
Thanks,
I guess
guys.
we'll say goodbye.
Thank you so much.
Thanks.
Awesome.
Have a good one.
Thanks, Nathan. Good presentation. Enjoyed that.
Bye-bye.
Thank you.